All right, so let's get into this EOC review here. So question number 1 says, what type of function is represented by each table? So let's look at table number 1. We've got our x values here, all increasing by 1. We've got our f of x values, our outputs, and we can see that they are increasing by, it looks like 3 every time. And so from the increase of 3 every time, we can say that this is going to be a linear function since the first difference is the same. First difference is the same. All right, let's move on to table number 2. So table 2, we've got the x values also increasing by 1 again. And then we've got this time, let's see if we can figure out some addition here. This would be plus 3, and this would be plus 12. So don't think that's going to work. So let's try something else. We could try maybe multiplying by 4, so times 4. And 4 times 4 is going to be 16. That'll work. And then times 4 again. Yeah, so it looks like we're going to be multiplying by 4 every time. All right, so if we're multiplying by 4, this is going to be an exponential function. So you're going to want to make sure that you know how to tell the difference between a linear function, an exponential function, and a quadratic function. Those are the 3 main functions that'll be on your EOC. All right, let's take a look at number 2. It says evaluate the function for f of negative 3. So when we are evaluating at a value, they want us to take this value here and replace it with x. Everywhere we see an x, we're going to put negative 3. All right, so f of negative 3, here we go. We've got negative 2, and whenever I substitute a value in, I want to use parentheses. So I've got minus 3 times another minus 3 plus 1. And we can use a calculator for this if we wanted to check. But if you also are able to do this without a calculator, that's cool too. So negative 3 squared is going to be positive 9 minus 3. Well, let's go ahead and do this. If I treat this as a negative 3 times a negative 3, I'm going to have plus 9. Or I could say that this is minus a negative 9. So either way, it turns into plus 9. Then I get plus 1. So last thing here, let's say we got negative 18 plus 9 plus 1. Negative 18 plus 9 is negative 9 plus 1. That's going to be negative 8. So we find out that f of negative 3 is negative 8 for that function there. All right, key features. What are the key features of the quadratic function? Graph below. So let's see, they want the vertex. So the vertex is the highest or the lowest point on a parabola, basically where it turns. So we've got a vertex up here. This would be a maximum, and it looks like it's at negative 1 and 4. So negative 1, 4. So our axis of symmetry comes right from the value of h, which is the x-coordinate of the vertex. And so we have x equals negative 1. All right, domain and range. So the domain of a quadratic function is going to be all real numbers. The range, in this case, we have a maximum, and our graph is pointing down, so the highest value we have is up here at 4. Everything else is below 4, so we'll say y is less than or equal to 4. And it's equal to there because we are including 4. We have a point at 4, that vertex there is going to be 4. All right, so end behavior. We have as x goes to infinity on the right side, or let's actually start with negative infinity. And as x goes to positive infinity, what are the y values doing? Well, this is a parabola, so both sides are doing the same thing. We see both sides of the graph are pointing down, so the y values are going to negative infinity. Or we could say decreasing. They're decreasing, they're going to negative infinity. Either one of those would be correct. All right, so now let's talk about increasing and decreasing intervals. When we're talking about increasing, I always imagine like a roller coaster, right? So we're going up on the function all the way here until we hit the vertex. Once we hit the vertex, we're going to be decreasing. The roller coaster is going down. So how do we write the increasing interval? Well, we know it's going to change at not 4, it's going to change at -1. So this is the tricky part about increasing and decreasing. It changes at the x value, so we want to think about that. So we're increasing before we get to -1. So we'll say when x is less than or equal to -1, we can just say less than. When x is less than -1. And then decreasing is going to be when x is greater than -1. So that's kind of like the left side, right side deal there. All right, moving right along. So let's talk about solving the system of equations. So we have this system here, and if it were up to me, I would use elimination because it's kind of set up for me to use elimination. And when I use elimination, I want to eliminate a variable. So I want to take one of these equations and change something about it so that when I combine the equations, one of my variables will eliminate. So if I could take one of these two x's and make it negative, then that would work. So I'm just going to take that first equation, multiply by -1. So I'd have -2x minus 5y equals -14. So now I can take these two equations, add them together. The x variables eliminate to 0. Negative, that's -1y minus 5y is -6y. And that is equal to 2 minus 14, which is -12. And so we can solve for y there by dividing by -6. We get y is equal to +2. So that's one of our answers. And now we'll take that number and we will go plug it in to, or substitute it into one of the equations. So it doesn't matter where. I could plug it into either or any of those 3 equations that I have up there. I guess I'll plug it into the second one. So let's see. Take this one here. I'm going to have 2x minus parentheses 2 equals 2. And so what do I do from here? Well, I'm going to add 2 to both sides. I get 2x is equal to 4 divided by 2. And I end up with x equals 2. All right, so what is the solution to the system? Well, the solution is going to be 2, 2. All right. Next one up, simplify the problem below using only positive exponents. All right, this is fun. Okay, so remember negative exponents, they kind of change direction based off of where they are. So up here, if we already have a negative exponent, this x is going to move to the denominator, and these are going to move up to the numerator, and their exponents will become positive. So let's just go with that real quick. So again, we're going to move x to the -4th. That'll become x to the +4, and that'll become y to the +5. The 3 down here, that didn't move at all. And then we have x to the 3rd power there. So now we can still simplify this because we have x to the 4th in the numerator, x to the 3rd in the denominator. And so we can simplify x times x times x. And basically we're going to be taking away 3 x's from the x to the 4th. And so we have x times y to the 5th over 3. So if you're confused about that, x to the 4th and x to the 3rd piece, we got x times x times x times x in the top, basically, and we have x times x times x in the bottom. And so that goes to 1, that goes to 1, that goes to 1, and we just have 1 x left. And so that's what we would end up with. All right, number 6. Determine the value of the expression. Write your exact answer with 1 radical. Okay, so we want exact, and we want 1 radical. So first thing we should notice is that we have cube roots here. So when you think about cube roots, you want to think about your perfect cubes. So what are my perfect cubes? Well, I got 1. I've got, because 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So I think we're going to use 8 here. And so because the reason I know that is because 8 goes into both 40 and 32. So let's think about this. If I was going to simplify this, I still have the 4, that doesn't change. But now I could write that cube root of 40 as, or if I just take 40, for example, that is 8 times 5. And so I still have the cube root of those things, but now I made them 2 radicals instead of just 1. And then 32, well, that's 8 times 4. And so I'll do the cube root of 8 times the cube root of 4. So now the reason why I'm doing that there is because I know that cube root of 8 is just 2. So that means now I can simplify this even more. So I have 4 times 2 times that other 2. And then I have times the cube root of 5 times the cube root of 4. So now, let's see what we end up with here. So 4 times 2 times 2, that's 8 times 2, which is 16. I can go ahead and multiply the 5 and the 4, which is going to give me 20. So I have 16 times the cube root of 20. And I can't simplify the cube root of 20 anymore. And so that's as simplified as I can get. And I only have one radical. So there we go. Moving right along, we got number 7. And they want us to graph the equation. So let's set up our x and y axis here. Put my x-axis there, or my y-axis there. And I'll put my x-axis here, I guess. All right, so when I have a linear function, all right, this is a linear. So I have a y equals mx plus b, so that's slope-intercept form. So my slope is going to be 3/4. My y-intercept is going to be -2. So I'm going to start with that. So I have -2 is where I put my y-intercept, and my slope is 3/4. Remember, that's rise over run, change in y over the change in x. And so we can go up 3 from that y-intercept, 1, 2, 3, and then we can run 4. And we're going to run to the right because this is a positive slope. So 1, 2, 3, 1, 2, 3, 4, and that's we have a point there. And if we wanted to do the opposite, we could go down 3 and left 4. And we get our other point there. And so that would be the graph of our equation. So now remember, your graph is going to be on the computer. So on this EOC, so make sure that you're getting some practice in with your computer graphing skills. All right, number 8. So 2 linear functions are given below. We've got f of x and we've got g of x. Which function has the greater slope? All right, so we know that the slope of f of x is -3. Slope of g of x, we want to know the change in y over the change in x. So how is y changing? Well, we're increasing by 2. And the x's are increasing by 1. And so our slope here is going to be 2/1, which is just 2. So which one's greater? Well, that's going to be g of x. All right, which function has the greater y-intercept? Let's see. Y-intercept, remember that's when x is equal to 0. So we know in f of x that the y-intercept is 2. But what is the y-intercept for g of x? Because when we only have when x is 1 in the table. So if we were to go back to when x is 0, we'd have to decrease another 2, and that'd put us at 3. So we have a 3 and we have a 2. So g of x is also the one with the greater y-intercept. Cool, cool. All right, so now the last question here is which function has the greater x-intercept? So that's when y equals 0. Or in this case, f of x and g of x. And so let's see how we can do this here. We can take 0, set it equal to -3x plus 2. Remember, this is for f of x. And we can solve for x. So we'll subtract 2. We've got -2 equals -3x. Divide by -3. And we get x is equal to positive 2/3. So that's going to be our x-intercept, is positive 2/3. So now, let's go back to g of x, and if we try to write an equation for g of x, we already found the slope is 2, the y-intercept is 3, so we could say g of x is equal to 2x plus 3. And so now we're going to take 0, set it equal to 2x plus 3. And this is for g of x. And we'll do the same thing. So we've got negative 3 if we subtract 3 from both sides, equals 2x, divide by 2, and we get x is equal to negative 3 over 2. So which one has the greater x-intercept? Well, this time that is going to be f of x. All right, that's a cool question. A lot of things they could ask you about two different functions. Number 9, write the inequality that represents the graph below. All right, so we know this is an inequality. This is a line, so we got a linear inequality. So y is something, and then mx plus b. That something there's going to be our inequality. We just got to figure out which one that is. All right, so let's see here. I'll put a box there so it doesn't look like 0. All right, so what do we know about this function? Well, we know that the y-intercept is negative 2. So b would equal negative 2. And then let's figure out the slope. So we can go up 2 and then left 2. And that'll put us there. So plus 2 minus 2. So the slope is going to be positive 2 over negative 2, which is actually negative 1. So we're going to have y is something, and then negative 1x minus 2, or just negative x minus 2. So let's think about this here. So because we're in slope-intercept form, if we write this in slope-intercept form, the direction of the shading is going to basically tell you your inequality sign. So since we're shading above the line, everything that's shaded is above, that's going to be greater than, and it's a dashed line, it's not solid, and so we're not going to have the equal bar because that would be a solid line, so this is going to be greater than. So our equation is going to be y is greater than negative x minus 2, or our inequality is going to be y is greater than negative x minus 2. All right, let's take a look at number 10. Solve the equations. We've got an absolute value equation. We're going to start this off the same way we would with any equation if that was like parentheses instead of absolute value. We're going to divide everything by negative 3. I don't want to distribute that in. I want to divide both sides by negative 3. That's going to save me some time. So these will simplify to 1. Negative 6 divided by negative 3. I have absolute value of 4x plus 2 is equal to positive 2. Then I'm going to set up my absolute value. So remember, absolute value equations, I have one equation that's equal to 2 and the other equation that's equal to negative 2, because if inside of the absolute value I had negative 2, well, the absolute value of negative 2 is just 2. So I have 4x plus 2 equals 2, and then 4x plus 2 equals negative 2. And the steps to solve are going to be the same. I'm going to subtract 2 from both sides, and I'm just doing both equations at the same time. And I get 4x equals 0, and over here I get 4x equals negative 4. So when I divide by 4 for both equations, I get x equals 0 on the left equation, and I get x equals negative 1 on the right equation. So there are my two answers. All right, number 11. We deposit $350 into an account that earns simple interest at an annual rate of 6.5%. If no other deposits or withdrawals were made, what's the total amount of money in the account at the end of 10 years? Simple interest formula is A equals capital P times 1 plus R times T. Okay, so let's think about what we have here. Well, we have P, that's going to be 350. We have 1 plus our rate is 6.5%. So 6.5% as a decimal is 0.065. So that's what we're going to have, 0.065 times 10. And that's going to be our simple interest formula. So if we simplify this here, well, yeah, let's see, that's going to be our amount. So, okay, so we have 350 times, and then we'll just do this in the calculator, 0.065 times 10. It's going to be 0.65, and so we have 1.65, because when we add that to 1, we get 1 plus 0.65. So 1.65 times 350, we will have $577.50 at the end of 10 years. So there you go. Number 12. You and your friend go to a store where all the shirts cost the same amount and all the pants cost the same amount. Okay, so you buy 4 shirts, 5 pairs of pants for $150. So let's write an equation for you. If X is the number of shirts and Y is the number of pants, we would have 4X plus 5Y, and we spent $150. Our friend, they buy 3 shirts and 3 pairs of pants for $100. So that would be 3X plus 3Y equals 100. And so we have a system of equations here just like we did before. And we're going to solve this probably using elimination. So let's get into it. So if we, in the previous problem, we multiplied just one equation by something to eliminate a variable. So if I wanted to eliminate, let's just say I wanted to eliminate the x's. Well, my common factor between, or not common factor, my common value between 3x and 4x is going to be 12x. So if I could make that, say, 12x and negative 12x, then I'd be in good shape. So the way to make 4x, say 12x, is just to multiply by 3. And then to make 3x, say, negative 12x, and multiply that by negative 4. So that'll work. So I'm going to multiply everything in that top equation by 3. So I have 12x plus 15y equals, that'll be 450. Negative 12x minus 12y equals negative 400. And at that point, I can go ahead and add them together. My x's will go to 0. 15y minus 12y is going to be 3y. And 450 minus 400, that will be just 50. And so y is going to be 50 divided by 3, which I believe, let's see, 50 divided by 3, that's going to be about 16.6 repeating, so we'll say 16.67. So remember, what does y represent? That represents cost per pair of pants. All right, okay. So now we're going to take 16.67 and we're going to plug it back into one of the 4 equations we have. So let's see. Let's plug it into that one there. So we have 3x plus 3 times 16.67 equals 100. And so 3 times 16.67, that is 50.01. It's equal to 100. We'll subtract that and we get 3x equals 49.99. And then we're going to divide that by 3. And we get x equals 16.66. So we find out that at this particular store, pants and the shirts cost basically the same. So 1666 and 1667. All right. Number 13. Equation of a parabola that has a vertex of 3, 4 and passes through the points 1, negative 12, and 4, 0. All right, so let's see. I know my vertex form of a parabola is a times x minus h squared plus k. They want my final answer in standard form, so I'll have to change that at the end, but we can work through that at the end. So let's see, we have y equals, we don't know a, but we have x minus 3 squared, because that's my vertex, plus 4. And then I can take either of those 2 points and substitute them in for x and y. So I'm going to take 4, 0 and plug it in. So y is going to be 0. I have a, then I have 4 minus 3 squared plus 4. All right, so let's solve. We want to find out what a is. So 4 minus 3, well, that's going to be 1. So I have 0 equals a times 1 squared plus 4. So that 0 equals 1a plus 4. When I subtract 4 from both sides, I get that a is negative 4. So my equation right now is y equals, not a, negative 4 times x minus h squared. not h, x minus 3 squared plus 4. All right, so that's in vertex form. I'd want to verify that when I plug in 1, I'm going to get negative 12, but we'll do that after we get standard form. So how do we get standard form from here? Well, we're going to distribute that out. So we have y equals negative 4, x minus 3, x minus 3 plus 4. So we have, let's just keep working here. So we got negative 4. That's going to be x squared minus 6x plus 9 if I do the distributive property. And then I have plus 4. So now I'll distribute negative 4. So I have negative 4x squared plus 24x minus 36 plus 4. And I have y equals negative 4x squared plus 24x minus 32. And that's going to be my equation of the parabola that meets those conditions. Now I would want to plug in 1 here for x just to see, make sure that it gives me negative 12. So negative 4 times 1 squared plus 24 times 1 minus 32. So I have negative 4 plus 24. So that's 20 minus 32. That's going to give me negative 12. And so I am good there. All right. We've got 3 questions left. So number 14, your school wants to maximize their profit from the sales of tickets to the homecoming football game. They determine the function that models the profit. They can earn in hundreds of dollars in terms of price per ticket in dollars. The function is given below. What price per ticket maximizes your school's profit? Okay, so if I want to find the maximum profit, remember this is a quadratic equation, so the graph is going to actually open upside down, something like that. And where my profit is going to be, my max profit is going to be up here, and that's the vertex. So how do I get the vertex from standard form? And I actually don't even need the whole vertex. I just need the price per ticket. And since the ticket price, since the ticket price is going to be t, I want to find the t coordinate of the vertex. So how do I find the h, or the x coordinate, or the t coordinate in this case, of the vertex? Well, if you remember, h has a formula. It's the negative b divided by 2a. And so my b in this case is 210, so I'll make it negative divided by 2 times negative 30. So I'll have negative 210 divided by negative 60. So let's do that in the calculator, and we're going to get 3.5. So that would be $3.50 per ticket. It's going to maximize our profit. All right, cool. Number 15. Write an equation of the line that goes through the point negative 2, 4, and is perpendicular to the line y equals 2 over 9x minus 5. So we need the slope from this equation. So the original slope is 2/9. The perpendicular slope is going to be, remember, the opposite reciprocal, so opposite sign. Reciprocal is 9 over 2. And now we're going to use our point slope form, which is y minus y1 equals the slope times x minus x1. And so we will have, let's see, this is our x1 and our y1. So we have y minus 4 equals negative 9 over 2 times x minus negative 2. So if we simplify this a little bit, we have y minus 4 equals negative 9 over 2 times x plus 2. Move up here. And I'm going to distribute that negative 9 over 2. So I have y minus 4 equals negative 9 over 2x, and then minus, the 2's end up multiplying out, so I just get minus 9. Then I'm going to add 4 to both sides. I have y equals negative 9 over 2x minus 5, and that's my equation that is perpendicular to that original line because it has the opposite reciprocal slope and it goes through that point negative 2, 4. All right, last question of this review. Okay, so 16. We know they want us to describe the end behavior and then describe what y is doing. Okay, so this is going to be an exponential function. And so let's just see what this would look like on a graph. If we were to, let's say, plug in 0 and see what y is, we have negative 2/3 times 7/9 to the 0 power. Well, we know anything to the 0 power is 1, so that's just going to be negative 2/3. So at 0, we're at negative 2/3. So just say that's there. And then, let's see what happens if we put, let's just do 2, just to kind of see where the graph's going. So we have negative 2/3, 7/9 to the power of 2. So 7 divided by 9, and then we're going to raise that to the power of 2. I'm just going to make this a decimal, so that's negative 0.5185, repeating. Okay, so that's still going to be negative. So really what this function's doing is like this. So let's describe the end behavior. So the end behavior, as x goes to the left, and as x goes to the right, negative infinity, positive infinity. As x goes to the left, the y values are going down, so we're going to negative infinity. As x goes to the right, the y values are going closer to 0. So remember your end behavior for exponential functions. We're approaching 0. All right, so then let's describe what y is doing over the whole function. So the values of y, they're starting out negative, and they're getting more and more negative. They're getting closer to 0. So if I start out at like negative 2/3, then I have negative 0.5185. They're kind of increasing, right? Because the numbers are getting bigger. So y is increasing closer to 0.